Right, well there's a sight you thought you would never ever see. Right, what we have got here is a broken milling machine. Yeah, there's some problems with it. This hand wheel, can you see it? No, you can't see it. This hand wheel is smashed off completely. And there's a good half-mil of play in there. This hand wheel, can you see it? Yeah, is smashed off. This hand wheel, it is had it. Right, so we can get you any higher than that. Wait a second. Right, here's the top of it. So, the motor is missing. The piece of paper I made. We have inside a packet of bolts, 3 to hold the motor on and the rest for the wiring and bits and bobs. 2 gears for the main shaft. The gearbox gears for changing between high and low. But the motor has the other gear on it. But these are bloody noisy, notoriously. So I'm thinking, since I haven't got the motor and I've got to buy gears, well, what motor have I got? This should have been a 150 watt DC motor, a 100 volt, a 200 volt, 150 watt DC motor. Well, here I have a 100 volt, 200 watt motor. So I've gone ahead, I've ordered some 5mm cam belt pulleys, 76mm in diameter, 48 teeth. So they will be approximately that size. So the pulley will go on there and it'll be, get it into view, that size. So I've got 2 equal size pulleys, one will go on the spindle and one will go on the motor will go in there, and I've ordered a cam belt of 400mm, which should be just about right to go in there. So I took the circlip off and I took the gears off and I put the circlip back on with the spacer because I might need the spacer. Might not, I might need to turn the spacer down a little bit, whatever. But for this, hope it's good. It definitely runs. The speed control that came with this is out of a exercise machine and it doesn't go slow enough. So I've ordered a speed controller for it. Although, if the speed control doesn't come from China, before I get the motor installed, then I will use the speed controller it's come with and have a limited speed of around about 800 to 1500 RPM, whatever it'll be. Recycling bin, let's see what we've got. Oh, full Monty, how's that? Here is the mini mill sitting on the floor. Does the can get anywhere close to a handle? It's close. It's not quite Carlin, but it's close. Okay, so I've hunted around and I've found a fish can, which will make a piece of plastic big enough, because we're going to be making some plastic. Okay, clearly, you know, most people will chuck away pieces of metal like that, or save them. For situations like this, they're plasma cutting cut-off bits. Now I've got my fish can, and I've got my baked bean can, and I've drilled a hole in the bottom of it. and I filled it with plastic caps. So this is after 20 minutes or so, and the caps are melting. They're going down. Everything stayed on the inside, hopefully. Got no dripping, I can't see anything dripping in there yet. Or maybe. Oh yeah, just starting to drip. So I'm just going to drop some more caps in there, and I've lined up some other caps which I've just washed, and a bottle which I've just cut up, and I better start chucking it in because it's going to start dripping now by the looks of it. Okay, so I started off with the caps and they came through. Then I started with the bottles, these body wash bottles, and then it stopped coming through. So then I put the rest of the caps in, and they had a little bit of the grey in them, and to try and force it down. And then I put this on top of it like that, with some pieces of metal inside it to blank that off, and some weights on top of that which have fallen off inside. Some weights inside there, and tried to press it out, but it was getting too precarious in there, so I decided, got a nice lump of plastic now, around about 2 inches long, about a bit longer than that, maybe 3 inches long and 2.5 inches in diameter there. And I'm just waiting for that to level out now. That's what I had left. I've just, the last swirl you can see just about inside there, that's what I managed to push out. So maybe that was another 5 or 6 millimeters I got out of it before it started getting too dangerous. And I'm giving that another half an hour. Hopefully it'll level out some as it floats in there, and it's in its molten state. So here we go. It's a bit flappy. This is carbide, so we'll put something a bit sharper in. That is sharper. Okay, I guess that was a little bit too much of a cut. Yes, it's come out. It's a bit slippy. I didn't clamp it too hard, I didn't want to clamp it too hard. Anyway, some nastiness in there. Nearly got a flat to go on now, nearly, close. think that's a flat now. Possibly get a centre in that now. Should get a centre in there now. If the centre will fit that far in. That is. Pull the compound out of the way. Wind on a few inches of centre travel. In fact, actually, I'll tell you what we'll do, we'll put the drill in. Definitely going to be able to get a drill in there now. Right, give me a second. I've got my biggest centre drill in there. There is a centre in there now. There's a bit more stability there, we've got a centre in it. The centre stopped turning. Something's gone wrong, the centre stopped turning. Not quite got all the void yet. Oh. I should make it turn again. So we can show you the voids. So right in the front now, it's going to zoom in. So you can see there's still a few voids in there. So I'm going to cut in until that void's completely gone, this one here. Not uniform, is it? Not really. But no, it's got a defect in it right there. Now, well, that will be bored out. Stuff just gets everywhere, doesn't it? So I was pooping along, and I suddenly decided that I was going to do the dishing. Then I decided, let's stop doing the dishing. So basically I'm going to use this little boring bar, turn the compound at a nice angle, and then cut in to dish it. And I thought, you know what, let's not, let's leave as it is. You can see it's a load of different pieces of plastic together, but not to worry, that'll do as it is. Because what I really need to do is get this broken handle attached in the back of it. So I think I'm going to attempt that, because I've got some breakout here. Pretty bad breakout. And I'm thinking to myself, maybe it's best to bore in from this side. Although I've just done that really nice. Very nice curvatures both ways. I think I'm going to be putting on from this side, and it's going to be a blank back on it, but we'll see. One collet. Touching off. Yep. There's a nuts left on it, that'll be right. I need to know what those two measurements are now. So I've just faced it off until there's a nice flat surface, and it's plastic, so I'm just going to let the drill wander in a little bit, and then we're going to go for it. Basically need to see where all the voids are and which side is best to bore it from. See what's happening. That wasn't very tight. Oh, I can see her. Hole and voids. Well, basically there is a void which is flush with this back end. Can't see any more voids in there, but you know, voids are voids, they will just come out of nowhere. I think I'm going to be quite safe boring it from the back end, so this is the other piece of plastic that I made. Let's see what this looks like. Yeah, I think I'm just going to face it with a boring bar, to be fair. It should be fine. Famous last words. Yes, that'll be fine. Oh dear. Let's see where I am for a start. I'll pull this all the way out. I've got to stop. So my stop's stopping me, and that's cleaning up nicely. So we'll pull it back a little bit, the stop. A bit more. Right. So I've got to stop. I can't go, physically I can't go out any further than that, and we're not touching the jaws, just not touching the jaws, so if I get a bit rambunctious on me pulling it out, we'll be alright. Okay, good clearance, good clearance. So I now have a disc of sort of uniformity. I don't know how wide it is. Let's take it out. It doesn't really matter, it's plastic, it's only a temporary wheel now. Look at this, it's not the greatest of plastic extrusions. Voids everywhere, but it should repair my wheel. And we've got 405 thousandths. Now I've got to decide how I'm going to attach it to the other wheel. See, I'm doing it again, I'm forgetting. I've plonked a hole through the centre of it. It's approximately an inch. It's going to be easy enough to get a nut and bolt through it. Now I am skimming down the outside to 2,000, oh sorry, 2.2 inches. 2,200. 2 inches, 200 thousandths. I'm going to double check my measurement. So that's a good 3 inches there. So I've got 800 thousandths to come off. I'm just going to double check. My measurement is 2.2 inches. So I can't chuck on this side no more, but that should fit into the wheel and make it look like a whole wheel. That's the best I can say about that. So I'm going to have to sort out my plastic casting procedure, because this isn't working at all. Is it? No, not at all. Ah, that's all we've got is what we've got. Yeah, there's a big void there. Sure, if I was taking lighter cuts that'd have been alright, but not to worry. So the place where the fracture is, I'm gonna put this bit, and I'm going to put this where the fracture isn't, so you can't see it. Now I have a gear blank. In fact, it's a cam belt pulley, exactly the same as this one. 8mm in the centre, I know that because it fits on the shaft beautifully of the motor. But the spindle of the milling machine, which this is for, is 20mm. So I'm just going to slacken it off a little bit, because I'm not entirely certain that I was being fair to it. What I've just done is I brought the centre into it, and we're all loose now. So that is nipped. That is nipped. That is nipped. And finally, that is nipped. So surely now, that should be somewhere close to central. So the pulley is bored to approximately 20mm. Now I've measured it with the metric micrometer and telescope gauges, and my imperial micrometer with telescoping gauges, and done the conversion, and it ends up at a 7/10 thousandths of an inch measurement. I can't remember what it was, and the metric is slightly under 20mm, which says to me it is around about 19.995, 997, round about there, somewhere about there. I worked it out at. It's very close to 20mm. I'm not going any bigger. That should go on to the 19.99mm shaft. screw tightened into it down there. And the pulley. Remarkably came with an 8mm hole in it. So on this side I don't have to do a lot apart from put a grub screw in it and we're away. And we'll do a cut, unlock carriage, advance, relock carriage, cut. And obviously the cutting motion is like this. Very repetitive. You can't see what I'm doing. You get the idea, it's just going to be going in and out of the bore, in and out, in and out. Well, maybe I was going the wrong way. All the way in there, all the way out, all the way into the stop, all the way out, all the way into the stop, all the way out, all the way into the stop. And I'll just be doing that repetitively. It's really annoying to watch. You get the gist. Bring you back when the broaching's done. So just before I start broaching, here's the setup. I'm just turning the light off, get this one glare. Got the carriage setup. Got a metric DTI on the back here. So I'm just going to bring it in now until it starts cutting all the way across. Set up the DTI to a 0 and then take 2mm. But this camera is right in my view, so I can't have that in while I'm doing it. So I'm just going to start doing that and do it all. So there is a keyway cut in there. .22 mil. I'd say that's about 2 mil. .05 as best as I can tell. This is the setup I'm using for the grub screws. So I've got a Morse 2 to Morse 1 adapter. I've got my micro Jacobs chuck in. I've just centre drilled and tapped to that one. It's close. Literally, I don't know if you can see this into the light. You couldn't get any closer. So that's turned out really good. Now I'll just put a centre drill into the top centre there. You can see that. And I'll just drill through that. And the way I lined it up was by eye with a square across those top teeth to the side here. So that's as good as you're going to get on a drill press without messing about too much. 2 clamps at the back holding it in, and clamp straight through. I've drilled through the bolt thinking, now I'm going to tap it all the way. I thought to myself, after I tapped it halfway down, I thought I can just, after I disassembled it, tap the rest of it. So this one's going to drill right down into the bolt, all the way through. And then I'll start the tap off, and I'll take it out, put it in the vice of the soft jaws and finish tapping the hole. Can you see what it is? It wasn't a waste of big piece of brass, but then I remembered I'd been saving old plugs from broken items, and they're about out of brass, aren't they? So I'm making some 4mm plugs out of that, since that's 4mm wide. That should be feasible. You'll see what they are in a second. I'm not going to record it, I'll just show it. Right, the wonderful noise in the background is the broken fan in the microwave conventional oven grill combination thing, which when you put the oven on it makes that noise for about 10 minutes until it heats up, and I just ain't bothered about it, to be fair, because it still works. So there we go, we'll have to put up with that. Now this is the pulley, It has 2 holes drilled in it and tapped for M5. Ooh. And inside the ball, when you turn it around, brass plug that side and a brass plug that side fall in, but not all the way through. They stay enclosed and retract near enough all the way. Not that it matters. Anyway, this Allen key helped me get it in, but I can't get it in any further, so that's no good. We'll have to use a proper Allen key. Flat on the shaft here. I think I want the spacer at the top here. I could have actually made a spacer for this. I'm not sure that I'm going to need to. Let's see. How does she goes? All the way down. No, she is clear. And then one tight. Two tight. Just let them seat. Right, now if you're using an Allen key like that, generally a pain in the arse because you can't get enough torque on it. What you need is a special adapter. This is me KS Tools special adapter for an Allen key. And if I can remember how to use it, it works great. And I can't remember how to use it. So you click your Allen key in like that, it holds it. I think that's in right. Yeah. So you see inside there, it goes inside that land at the bottom, and then it clicks into the teeth at the front here. I think it can click in. There we go. It clicks all the way into the clicky thing, which holds it. And this says it can hold a 3 to 10, and this is not a 3. This is a 2.5. So I think we're pushing it a bit, and then you can tighten it up the last little bit. And that's tight. So now we have a pulley on the DC motor. Right, so in the background you can hear the oven still going. These are the old gears. I don't want to leave them in there because these will probably melt when the heat goes in there. And we don't want to leave that there because that will definitely melt. So I just want to make sure the shaft is clean before I put it in. It's going in now. No chips or anything inside there. The original spacer. That's in there. There's no bits on its flanges. So when we get the oven gloves on, fingers crossed this will go in. Now it might spit at me, so I'm going to put some safety glasses on. So I'm going to go and get it. Not to keep it from the heat, but that's beauty, it's steaming. Yeah, I think it's still in there. Now please, go in. Just down. She's not all the way down though. Does she come off? No, she's not all the way down. Oh bugger. Quick, 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 quick. Big socket. It's going to have to have a socket drop on it. Problem, I didn't machine it deep enough. Oh man, no. Is it going to come back off again? Yes it is. So, problem is, I didn't machine it deep enough. Ow, that's really hot now. So, I'm going to have to let it cool down again. Good news, it fits. I'm going to have to let it cool down again. And then I'm going to have to put it back in the forward jaw, set it all up again, and the circlip groove was just visible. Just visible. And the circlip, I can't believe, £1mm. 1mm is stopping me from fitting that. Well, it was just a guess at the depth, and the guess wasn't quite calling. So I am setting about tramming the mill. First I stoned the table. There was quite a lot of rust over here. I stoned it completely flat. I tried a vice on it and it hinges perfectly, so it's got to be flat. That's pretty good. But we have some problems. So I drew a piece of paper to help me do this, and I started here and 0 was 10th out, and it went down to 9.5 thou there. Then we're up to 10.5 thou there, so that is here. Around here. 9.5 thou, 10.5 thou, 10 thou. So it's not quite the column. Not only is it tilted X, it's also tilted Y. So there's 20th out the back, 24 at the front, and there's 35.5 thou there and 35 thou there. So the table needs to basically go like that. So that means the column needs to basically go like that. So the column's off the machine, and we're just looking at the surfaces before I stone them. And clearly there was a high spot here and here, and that one's low. So I'm going to stone it now and we'll see what it tells me. We'll stone that, because obviously the high spot could be here as well, right there, and that bulge, right there. I can feel it, it's right there. It's the high spot just here. Yep, that's it, right there. I can feel it. Right, here we go, stoning it. Yep, you can see that high spot, can't you? Right there. So there's a bit of a high here, and a massive high there. So yeah, and obviously that's low. So I'm going to stone this side a little bit more until that goes down. And then I'm going to stone both sides until they look even. And I think that will bring me somewhere close. And on this one, yeah, I think just stoning this is going to get it somewhere close. Oh, but you'll have all my plastics bags down there, don't you? Yeah, absolutely lovely. Alright. Yeah, I've just torqued it up to 20 foot-pound now. Excuse me. So that's stoned, refitted, and then torqued all bolts to 20 foot-pound. So I used the fine feed adjustment and I brought it down to 9.5 thou there, so it's exactly where it was before. Now we're just gonna, if I can, spin it round. This was 20 thou before right here. So we've got 10. We're down to 17 there now. 17. This was 35 here. 10, 20, 30. Sorry, 10, 15, 20, 25, 30. 30 there now. It's 35 and a half. 20, 25, 30. Oh, grief. Right. 15, 20, 25, 32 thousandths. And that is 22 thousandths. So I've made a couple of thou difference. Right, I've made an extremely accurate jig using a really fine pointed pencil and the most accurate measuring device I could find. There's more measuring devices, but that's good enough. And these should be between 47 and 48 millimeters apart. I can do it without moving it. So obviously if I start this hole towards the left hand side a little bit, that'll be fine. If I get this one crack on, that'll be fine. So I don't think it turned out bad. Not quite circular, as the drills I used are rubbish and the holes drifted, but not to worry. Look alright. I mean, it's not square anyway, you can see it's not square, but if it fits, it fits. Let's find out. So, she's in. I torqued them all up to 20 foot-pound, and I've over-torqued this front one here to about 35 foot-pound. I can't get it much tighter than what it is without feeling bad about it. So that one's staying where it is, and I've set a 0 this time, and the 0 is there. Yep. So right around there, it is minus 2.5. And there it is minus 2.5. And there it is minus 2.25. There it is minus 2. And now we're back to 0 again. So I still need to pull this side down a little bit. So I'm going to over-torque this bolt a little bit as well. I could do with about half a thou finish in really. But that's what I'm doing. To get it as close as possible. 2 thou isn't the end of the world. Over 100 mil. Not bad. It's a lot better than 20 thou. So this is Moment of Truth 2. As you can see, I've cleaned it out a little bit since the last time I tried it. I've turned off another 1.2 millimeters off the ball at the bottom. I've cleaned the spindle, cleaned the spacer, cleaned the woodruff key, and hopefully it is now going to go all the way down and allow me to get the circlip on. That's going to be crappy old oven gloves. And I've only heated it to 150 degrees this time because it seems it's a little bit hot maybe. The spindle was red hot when I took it off yesterday on there for about a minute. So let's have that there. And that down. Yeah, it's there. But can I get to the circlip on? Oh, you joking, yeah. It looks like I'm just not going to be able to get the circlip on. Maybe I should have took 1.3 millimeters off, because that looks like it's not good. Please go on. Oh, it's in. Yay! That's just perfect. Couldn't have got any better than that. Because I took 1.2 mil off and not just 1 mil. It was just a guess. But she's on. Right, I need to cool it down a little bit. Let's get a wet sponge and cool it a little bit, because that'll be a little bit on the warm side. We'll just let some evaporation happen on top of that. You should see it evaporating. Just to cool it down a bit quicker. There we go, the gear is on. So this is inside, and I've set the height, as you can see, and that looks pretty much perfect. That's going to be close enough. There's a gap in between it, so they still spin independently. I'm just going to put the belt round and set I can make them just mesh into each other. There won't be very good gears though, will they? So I've got to set the distance, which will be something like there. And after I set the distance, then I'm going to mark out and drill the holes. The other thing is, initially I had the pulley pushed all the way down the shaft, but as you can see it's a good centimetre out there now, at least a centimetre. And I was worried that with 2 grub screws one was going to come off the end, but it ends up that it is perfectly on the end, that last one. So the other grub screw, that grub screw there as you're looking there, and then this one here has definitely got a good bite on the shaft. So it's all worked out for the good. So far, so good. I was having tracking problems, so I've made a cam belt tensioner out of a bit of plastic, and I checked it and these bearings pressed in. I turned it, didn't touch the inside, and then the bearings didn't press in, so I've glued them on. If that doesn't work, then I'll get a piece of aluminium can, cut it to the length, and then press the bearings in with the aluminium can around them. That should keep them equal distance, but we'll try it with super glue for a start. That's 2 bearings inside that, and that will stop it. It will put a bit of tension on, I think. I don't want it for tension, but I've put 45-degree chamfers on each side to keep the belt in the centre. And hopefully that will track in the centre in both directions now, forward and reverse. So we're back at the lathe again, and I've got to make that. You might think, what's that Z-shaped thing there? Well, it's a cam adjuster for the cam belt follower, which doesn't quite touch properly. It's about 0.5 millimetre out, but it still rides off it, so I need a little bit more tension. So I'm going to have 8mm offset. I've got a piece of 70mm bar in here. There's an 8mm offset on that. That's how I set the kite chuck up, so you'll see it's not central. So now I'm going to make a cam with threads on both sides. Fully threaded one side and partially threaded the other side. Happy days. So we're getting somewhere. I've got these little hold downs which I made for my faceplate. They're tapped for 5/16 BSF. So obviously 8mm hardware goes through it, and these are 8mm slots. The T-nuts for the faceplate don't fit in there, but there's a couple of options I've got, if I can find them. I've got some 14mm weirdo nuts that came. They're 8mm 1.25 and they fit in just about perfectly. So before I've made the T-nuts, which I'm making the T-nuts out of that, I have options. We are in and screwed down to the bench. It's quite sturdy-ish. So this is the operation. It is on. I think the cam belt's a bit tight, so I'm going to have to do some adjusting there, I think, which is on my cam here. So I'll just back it off a little bit. Ooh, there she is. Ooh, what's happened? I think I've got a different mode going. I've made the drawbar. Great machine. 3, 2, 1, start. Awesome. So, there we go. So I had an engine bolt out of an engine mount, and it was too short. It was about that long. So I got a piece of crappy mild steel, and while I was turning it, it jumped out the chuck, hence the bite out of it there. Then I attempted to drill it. It was just quite funny. And it overheated and melted some high-speed steel drilling to the end here. It was hilarious. So anyway, there's a bit of drill stuck in there, which is melted with a 4mm hole in it. So instead of this being 8mm all the way down, it's got an 8mm land on it, and then a 4mm tit on the end of it to fit in between the high-speed steel, and that's glued in with Loctite. And when I pressed that side, it swaged the end out, so I've turned it again. Same on this side. This really seriously swaged the end out. This is just pure 8mm all the way down the centre, and some mild steel, a bit of grade 8 at that end and a bit of grade 8 at that end. Right, this could be disastrous. It's a brand new cutter, and this could be seriously disastrous. Especially because I'm on the wrong side, I believe, because that's going to be climb milling, so I'm going to come on the other side, touch off on this side. So I'm just going to touch off on this side and take a really light cut. Well, so that was touched off already, so I'm going to put on a There's no heat in the park whatsoever. It is stone cold. I'll show you that. There we go. Let me just zoom back out again and bring it in. So, very nice job. I mean, it wasn't a very deep cut, but not a very deep cut at all. That was an extremely nice cut. Now, taking 600ths of a millimetre off. It's still 8 hours to do anything. And as we could hear the rotary body now, that seems to be a nice speed for that cutter. So I might try a small cutter at a high speed and see if I can get a 6mm cutter or a 4mm cutter in, and we'll try that. I'll do the measurement and I'll get the smallest cutter that will take the whole cut in one. We'll see if we can do 1/2mm cuts or something like that and sweep up and down it at a higher speed. But yeah, that's silky smooth.